So my name is Lindsey. The species I got, and also like highly great with my saying it, is the Chlamydomonas. I always say it wrong. I'm sorry. That was just a cute little cartoon about. They look similar to that. Just press that. Okay. So the background on my species is that it is eukaryote. The kingdom is Plantae, phylum Chlorophyta, class Chlorophytaceae. Order is Chlamydomonas. Sorry. Family is Chlamydomonas, and then my genus, which is Chlamydomonas. And there's surprisingly a lot of them. There's 594 that I found on AlgaeBase, and they're kind of spread out all over the world. It's not just central to Hawaii, but from that I found two species that I'll go with some important features first. So they are unicellular. They have an eye spot, and that's how they find light in order to photosynthesize. And then they contain a glycoprotein wall and two equal flagellae. And for the glycoprotein wall, that contains 50% protein in as part of their cell wall. And then for reproduction, they do asexual and sexual. When they do asexual, it is through fission. And then that is kind of this diagram that I put up about their life cycle. And so it's the sexual reproduction and then the asexual. And then when they do sexual reproduction, it is through, they just fuse into pairs, and they have the 4 cells. So for the Hawaiian species, I found 2 species that were in a study, and they looked at how when they photosynthesize, they photosynthesize making carbon dioxide and hydrogen gas. And so some of the characteristics of these is that it's the same, it's mixotrophic, so it's autotrophic and heterotrophic. They have 2 flagellae, which they use to swim around. And then these 2 are freshwater species. They were found in Laie, up on the north side, and they are soil dwellers, and so when they're in the soil at first they don't have their flagellae, and once they get exposed to light then they will develop those. They are egg-shaped and spherical, and so on here it's hard to see, but the flagellae are 2 right there, and then the stigma is where the eye spot would be, and that's where they would use to help find the light. And then the vacuole helps with their hyperstatic suspension. It helps keep them centered. And then, the pyrenoid is what helps the CO2 fixation for them. So the studies that I found that were on it was by a German biologist, and he pretty much researched and found that they produce hydrogen gas and carbon dioxide also, and then he just wanted to understand the basic mechanics of how algae and bacteria have that in common, and they photosynthesize, and through hydrogenesis, which is the similarity between the bacteria and the green plants. This diagram right here was in the paper, and it pretty much shows the main electron transport pathways for the hydrogen production. I tried to understand for the most part, but as I followed the arrows, it helps with the flow of how it happened. And then 60 years later, they continued doing studies on it, and they pretty much just discovered that the hydrogenase containing algae, in the dark, they produce hydrogen and carbon dioxide into the environment. So they release into the environment when you're in the dark. And then from there, they just used that and applied it to different other species of green algae or different plants and bacteria and how they have that in common.